All right, so I want to welcome you guys to NDC, second day. It's fantastic. Competing with a lot of really great talks, but I think every speaker and every track can say that. So I really want to thank you for coming to this talk. Like I said, we're going to be talking about building scalable and maintainable apps using TypeScript and React. So, my name is Kamran. I work at Target downtown. On the side, in addition to my full-time job, I do some Pluralsight courses. I have one on RavenDB, one of the sponsors here at NDC. I also contribute to a game engine called Scalable.js. It's written in TypeScript. That's sort of where I got started writing TypeScript. And I also have an application called Keep Track of My Games, which is a game organization app. It also lets you track upcoming releases, sends you notifications, and that served as the inspiration for this talk, which I'll get into. At home, I have a wife and son and a dog, but she's black and white, not brown and white. On the side there in the picture, my wife and I spent 6 months in Europe on a sabbatical, and we visited Morocco, so that's a monkey from Morocco. I also enjoy doing tabletop RPGs, board games, video games, programming on the side, as you could probably tell, listening to audiobooks, and I own 2 guitars that I don't play, so those are my hobbies. You can see that gaming sort of runs through the line of stuff that I do, and that's one of my passions. So, why am I here today, and why are you guys listening to this talk? So I just want to sort of go over my motivations for this talk. What do I want to achieve when I'm writing and working on my applications? So, one of my goals is to make my apps easier to maintain, and one of my goals is to make them easier to scale. But what does that actually mean? I want to make sure that we set the baseline for what I'm going to be talking about. So when we are talking about scalable code, are we talking about something like this, where you want to support 99 levels of navigation, so therefore you create 99 jQuery selectors? This, by the way, actual production code that we found in one of our code bases. I mean, how else would you support 99 levels of navigation, right? Because recursion's not a thing, and CSS selectors don't support nesting. So we are not talking about this kind of scalable. What we're talking about is making our code easier to extend, and by that I mean adding new features. Usually you hear this term MVP. We're working on an MVP, right? It's our minimum viable product. But then we want to add features down the road. So how do we plan for that and make sure that our code base can scale? We also want to make it easy to collaborate on. I work on a team of 5 other developers at work, and we want to make sure that we all have work to do. We don't conflict with each other. We're working in the same code base. And we also want to make it easy to reuse code and update code. That also means for maintainability, we want it to be easy to refactor, and this is where TypeScript comes into play. We also want to make it easier to understand. And by that, I mean coming into a new code base, as I'm sure we all have come into new code bases, just try to measure the time. How long does it take you to fully grok an entire code base? And usually it's like 6 months until you fully understand everything that's involved. What TypeScript allows us to do is describe the stuff in our application a little bit more precisely, so it's easier to get onboarded. And you'll see what I mean when I talk about TypeScript. We also want it to be easier to test. We write tests. We aim for about 85% code coverage. Not that that really matters. What we want to do is we want to write tests that are valuable, not just write tests for the sake of writing tests. And TypeScript allows us to write more robust tests because they are also type checked. So that's what I mean when I say scalable, maintainable. TypeScript, if you are new to TypeScript and you're not familiar with it, it is a compile-to-JavaScript language. It's transpiled. It offers static type checking. This is one of its most powerful abilities. That's why it's called TypeScript. If you're coming from C# or Java, then you're probably used to static typing. But if you're coming just from pure JavaScript, JavaScript is a dynamically typed language, not a statically typed language. But TypeScript sort of brings the best of both of those worlds, where you can mix both dynamic typing and static typing. It has really, really good editor tooling. And I'm on my laptop, and so I'm going to be showing you all these code snippets in the context of Visual Studio Code, which is the editor that I use, and you're going to see what I mean when I say fantastic tooling. It also helps you provide more refactor-friendly code. Because the TypeScript compiler is understanding your code base as you write it, that also means that it can find all your references, it can keep track of where things are in the code base, and so you can usually hit a hotkey to like go to where things are defined or find all the references to something. When I came into my current team at Target, we're just doing a pure JavaScript code base, and the way that people find references in a pure JavaScript code base is by doing Command F across the file system. Right? So you don't do that with TypeScript. It knows where everything is. React is a component-based presentation library. I wouldn't call it a framework. It has a very small surface area. The API is pretty small. You basically have components, and then those components can have some methods on them. But it allows you to compose your app as small, reusable units of components. So React has a more functional mindset than, say, Angular, where you're creating components and decorating them with ES6 decorators and stuff like that. So React is, what I like to say, is just a little bit closer to the metal. If you're a pure JavaScript fan, you're probably going to be a bigger fan of React than you would be of Angular, but they both have pros and cons. The reason that I chose React for my application was that it has really good performance. Because it's based on the virtual DOM, it's able to have a representation of your DOM, and it's able to detect differences, so it doesn't have to rely on the browser APIs, which are a lot slower, so it has very fast performance. So this is a code sample of using TypeScript with React. I have these cool buttons right here. If I click on them, they're going to bring me into Visual Studio Code, into the file. So this is an example of using React. Here I have a functional component, a stateless functional component. And really it's not that different from just regular JavaScript. This is just a function using arrow syntax. And it has a single property called props. And it's rendering an H1 text, and this is JSX. So if you're not familiar with this syntax, this is like HTML in JavaScript. Well, you can also see that I have this funky syntax here. This is from TypeScript. So this syntax is what's called a type annotation. And what it is it's describing what these props are. And the way that you can read this is similar to how you would read regular JavaScript syntax. This is an object that has a text property, and that text property is of type string. Here's another example of an ES6 class component. This has an even funkier syntax here called generic syntax. So the way that you can read this, these two generic parameters, the first one represents props, the second one represents the state of my component. So the way that I would read this is I would say class app extends React component of empty props, because it's an empty object, and state props that have a hello property that are type string. And you can even see here that I'm initializing my state to hello Kamran. So what is the benefit of this? Well, with TypeScript, if I, for example, change this to a Boolean, suddenly I'm going to get some red squiggly lines. And the squiggly lines are going to yell at me, and they're going to say, type Boolean is not assignable to type string. So this is one of the primary benefits that you get with static type checking. It's saying that I can't convert a Boolean to a string. That's not what you told me it is. However, if you go ahead and change that to a Boolean, then suddenly you're okay. But if you check out down here, I'm referencing my other stateless component. I have my text prop, and I'm trying to pass in the current value for this .state.hello. Well, this .state.hello, as you can sort of see here at the very bottom, is of type Boolean. Well, Boolean and text, Boolean and string don't jive together, so TypeScript is also going to throw an error here because I'm using this component wrong. So one of the reasons that I chose to use React or static type checking with React is that I get full type checking all the way down into the JSX, which I think is really powerful. So let's undo that there. Fantastic. Now, the inspiration for this talk came from an application that I run. It's non-commercial. It's totally free. It's called Keep Track My Games. What it allows you to do, like I said, is sort of organize your game collection. But initially, I'd created it to track upcoming games. And so context around this was built in .NET. So historically, I've been a .NET developer. And it's also a hybrid app. which means that it has server-side rendered pages, and then inside of those pages there are pieces of JavaScript that enhance it, that make it more of like a single-page app experience. And originally, I had written this in jQuery and Knockout.js. So what I've been doing over the past year is migrating that to TypeScript and React, and that sort of served as the genesis for this talk. So a lot of the patterns that I'm going to talk about have come experience from that, as well as projects that I work on at work where we do TypeScript, Redux, and React. I chose React because it's a heavily interactive UI. So this is an example of sorting your game collection. And this is the React version, so I'm using some fancy animations. But you can see that people can pick whether or not they want to prioritize certain games in their backlog. But then when they switch it to a different sort, then the icons change and a lot of the props and rendering changes. So I was running into performance issues with this because this is supposed to support thousands of games in your game collection, and React is allowing me to do this type of thing. And that's live, right? So React is super powerful for that. This talk is based on a true story. And what I mean by that is that I'm going to show you patterns and practices that I've come to think are useful. And we've implemented a lot of them on the projects that I'm on. But I'm also showing you ideal pattern state. So my entire code base isn't necessarily migrated to all these patterns yet. But I think they're going to be useful. So the concepts that I will mention include the Redux store. So if you've used Redux before, it is a state container for your application. It allows you to manage global state, and that is supposed to be your single source of truth for your application. And it can be pretty heavy for a small application, but if you're working on a big production app where you have to support lots of people across the world, like at my project, it's really useful because you can ship that state in debug logs and stuff like that to be able to reproduce people's errors if they run into any. State is the data representing your app at a point in time. One of the benefits of Redux is that because it's tracking state over time, you can go back in time, you can step through your state changes, and it's keeping track of all of that. Actions in Redux are just a fancy word for a JSON object with a type property. And that type property can be anything. In my examples, they're going to be strings, but with a certain twist with TypeScript to make them strongly typed. Action creators is just another fancy word for a function that returns an action. That's all it does. So it takes some parameters, and then it outputs a plain old JSON object. The reason that we have action creators is so that we are consistently creating actions across our code base. And reducers are another term that was really confusing at first, but what they do is they take those actions, and then they return a new updated state based on those actions. So let's say that I want to fetch a game from my server, which is one of the examples we'll see. It will take that game response from the server, and it will shove it into the Redux state. And that's a new mutation of the state, therefore it's a new representation of our state. Great. So what we're going to talk about today, we're going to take a look at some patterns about folder layout and structure, state and reducers in terms of Redux, actions in Redux, action creators in Redux, and finally we're going to talk about plain old React components and how to manage their state. So for folder layout, this is a common layout that you'll see if you're starting out learning React, which is the generic folder layout. And by that, I mean that there are generic folders like actions, components, reducers, selectors, which are just ways to get information from state, and just regular generic services. Well, this works okay for a small application, but the issue with this is that files are going to be spread out. The components folder isn't going to scale very well because these folders are going to start to get pretty deep. And if your app starts to grow, there's going to be a lot more folders. In addition, like I said, it's fine for a small site. But what we really need is something that scales a little bit better. And this layout is inspired by Ryan Florence. And he proposed this way to organize a React application by screens. So you can sort of see here that we have a screens folder. Inside of our screens folder, we have an app folder. That represents our shell for the application. And all we're doing is we're just having a convention where each screen folder can have a components folder, which is your components that are used in that screen. And then we have a shared folder, which is going to be a little special. This is a way to share components between that screen and any subscreens in your app. So what this allows us to do is achieve a scalable nesting layout. So let's jump into the code base quick here. So here is my screens folder, my components folder for my app. I have subscreens. So my app is my shell. Now I want to maybe show a game details screen. Well, that's its own screen down here. Or maybe I want to show the list organize screen, and that has its own components that are being used there. In my shared app state or shared app folder, I have like an icon that I might want to share across my application. An icon's probably a good thing to share across your app. So how do I actually reference those shared components? This achieves better collaboration, co-locating related files, closer imports. I'll go over those again. This is how you would normally refer to a shared component. You'd use this ... Well, we're talking about scalable nesting, right? So I can have lots of different subscreens. This ... is going to be repeated a whole lot of times as soon as you get 2, 3, 4, 5 levels deep. That's not cool. So what we're going to do is we're going to do a cool thing, and we're going to fix TypeScript to actually resolve modules using a convention where we just say shared /. And what that's going to do is it's going to emulate how Node resolves modules, and that it looks in the current directory and then just keeps going one directory up and tries to match that module name. So you can see that because I'm using TypeScript and I've configured it correctly, it is finding the exact location for that module, which means what I can do is I can hit F12 and I can just go to the definition of that module. So there's no hunting and pecking around trying to figure out where these modules are. It's able to resolve that. How exactly does that work? Through this magic right here in our tsconfig JSON. So there's two properties, base URL and paths. And what I'm doing here is I'm setting up aliases. So I'm saying anything that starts with ~/ you're just going to map it to the source directory. Anything after that with the star is going to be substituted. In addition, I'm also going to do shared /star. And you can see that I've mapped screens, app, shared. Anything after that is going to be mapped there. Now, you might be pointing out or thinking to yourself that this is neat, but what isn't so great is that I have to define all these shared folders statically. There is an open issue for this in the TypeScript repository. They're hopefully going to address it. But honestly, as soon as you start adding screens, you're probably going to have an initial batch of screens, and then as you work on your application over time, this file is not going to change that much. I don't find it to be a huge deal. If you really want to go the extra mile, what you can do, I have a code sample right here. You could take that tsconfig and you could mutate it, and you could go ahead and search for all the shared folders and just add them to that paths property and then generate a new tsconfig. And you could add this to your Webpack config, or you could add it to your NPM scripts. I'm not going to show that, but this is the code sample that does that. All right. So what do we achieve by doing this folder layout? We have a scalable folder structure. We have shorter import paths. We have shared component resolution. And it supports the TypeScript go to definition functionality, and even you saw in VS Code, it was able to support VS Code. What's not so great, of course, is that you are currently forced to provide shared paths. Okay. Redux state. This is interesting because when you start out using TypeScript and Redux, what I had initially done is I had tried to describe my entire Redux state as one single TypeScript interface. An interface is just a description or a contract for the shape of an object. So what I was doing is I was just saying, here's my entire application state, and here's one file that has it, and it didn't really scale very well. What I'm going to show you right now is something that we can just call bottom-up state. So bottom-up meaning it goes from the farthest screen down and then bubbles up to a final exposure of our state in a single type property. So how does that work? This is the root of our state. We have our source/state, that's the index.ts that we're in right now. And all I'm doing here is I'm importing our app state. That's our first screen. Remember, it's our shell. So app is going to have its own state. And what we're just going to do is we're going to import that state, and we're going to expose it. And what we're going to use is this keyword here called type of. And what does that do? So what type of does is it actually, in TypeScript, just gets the definition of that type and exposes it as its own type. That's a little bit meta. So what it does is it's actually just describing what that shape is going to look like when it's finally done, so that we don't have to declare it up front. So I'm going to use go to definition. I'm going to find out what does this state look like. So this is our app state. I have a game property on it. That's from my subscreen game. You could imagine here that I have multiple subscreens, like my list organize page, my list edit page, my list create page. They're all going to have their own state, and I'm going to export them right here. Let's go farther down. So now we've reached the bottom, and the bottom actually is the one that has the interface. So this is my game screen state, and my game screen state has a details property. That details property has an ID, that's a number. It can also have a game that could be null or an object, and I would actually have an actual class here if this was a real application. But then I'm defining my initial state, and I'm just saying that it's going to match this shape. Why do I do that? Why couldn't I just do this and just export this? Well, if I do that, let's say that I add a new property, what's going to happen is that TypeScript's going to be okay. This is just a lint error. TypeScript's going to be okay with this, but that's not what I want. What I want to do is I want to enforce that this object matches my game state, and now I'll get a TypeScript error, and when you scroll all the way down, it says, object literal can only specify known properties, and I don't know about foo. You didn't tell me about foo. Foo is not up here, therefore there's an error. So that's going to help us make sure that our state is consistent throughout the application. We're not passing extra properties that we don't know about. I just went through this. That's bottom-up state. What about reducers? Can we do the same thing with reducers? Yes, we can. So we're going to do bottom-up reducers. This is, let me just close these. This is the root reducer. This is the final reducer that gets created, gets put into our store. I'm going to hit F12 on here. This is my app reducer. This should look a little familiar. I'm using the combine reducers function from Redux, but I'm also passing an extra parameter here. What's that for? So the generic syntax right here for state. What I'm doing is I'm just passing in that exported type from earlier, state. So as a reminder, that's what I'm putting as what my reducers should look like. So then I'm importing my game reducer. That's from my subscreen. So I'm going to go to my game reducer. And I'm going to do the same thing. I'm just going to combine reducers from all the parts of my state that are part of my game screen. In this case, details. And we're just going to go to the short version of details. And this should also look familiar because this is what you would typically do in a Redux application. For a reducer, you would just have a function that takes some state. By default, I'm just sending it to our initial state. What's initial state? Initial state is that constant that I created that I exported. So that's our initial state. And then I'm taking an action. And for now, action can be anything. But we're going to fix that next. So now I've created bottom-up reducers. So I don't have to define what my reducers all are going to look like. I don't have to import them all at the root of my project. They're all defined in their screens, and they're exported, and then they just sort of get composed together. So what does that buy us? We maximize type inference from TypeScript. So what I mean by that is I'm saying I'm not describing my entire state up front. I'm allowing it to be composed from all my subscreens. That's bottom-up composable state. So screens manage their own state. They're encapsulated. So each screen has its own representation of state, and then it just gets exported, and then I just consume it. And using that shared folder, you can imagine that I could actually just create shared state. So in my shared folder, if I created a stores folder, I could potentially create multiple Redux stores if I want to, and they could be shared between screens or subscreens. Okay, what about actions? Reducers handle actions. We need a way to represent those actions in a way that we can make sure they stay consistent. So this is what my actions look like. We have load game. That should be familiar. In Redux, usually actions are constant strings. So we have my load game is one of my actions that I have. And then I have this interface, this TypeScript interface, that describes what that action has. It has an ID, it has a game object, and it's extending this thing called action, but I'll get into that next. Why is it significant that I'm exporting a const load game? Besides being a typical thing that you would do in a JavaScript app, is if it doesn't change, it would be const. But const has a connotation in TypeScript. What it will do is it will give it the type of the literal string that you're giving it. So the type of this load game variable, this constant, is the literal string game/load. Okay, what do I mean by that? If I change this to a var, then the type of load game is a string. So TypeScript doesn't understand that it's a very specific string because it's a variable. It could be, you could assign a different string to this, so it's not a literal type. But because I'm using constant, the literal type of this is game load, and you'll see the significance of that in a second. Now, this helper that I've created is really simple. So pay attention to this code right here. All I'm doing is I'm describing an interface, a TypeScript interface, that takes a generic argument, the type of my action, and I'm just, by default, I'm setting it to string. Generic defaults are really cool, and I wish C# had them. But in TypeScript, you can set the default of a generic argument, and I'm setting it to string. So it really could be anything, any type of string. But what I'm doing here is I'm saying, I'm using that special type of operator again, where I'm saying, I'm creating an action of this literal string right here, game load. And that is going to be substituted in this type property. So actions all have a type property. That was one of the things that Redux enforces. And now I'm describing that type. And my load game action has ID and game. All right. So what does that get us exactly? Well, this is back to my reducer. Now my reducer has a little bit more code. We still have our initial state. That stayed the same from what I showed you. But now, rather than typing action as any, we're typing it as this thing called game action. So remember that I'm in my game screen. My game screen is going to have several different types of actions. How can I tell TypeScript that my actions could be one or more of these actions, these types of actions? So I can do that using something called a type union. In TypeScript, this is just saying game action can be load game action or save game action. So it can be one or either of these. And as you can imagine, I could add more. So I just use the pipe operator, separate other types of actions that this could be. Okay, that's interesting, but why do I need to do that? Or why should I do that? Well, remember that we typed action.type in our helper. And we substituted that literal constant value as what the type property should be. Well, if I hover over this, you can see that TypeScript has inferred that the two types that it could be is game load and game save. This is what's called a discriminated union. This is significant because what this means is that I can take advantage of TypeScript's type guard functionality, where I can say, hey, when I handle the load game action type, then I'm going to get IntelliSense and type checking for everything on that specific action type. So game and ID are both properties of our load game action. But if I come back down here, and I've created another action I didn't show you called save game. Save game does not have a game property. If I go here and I hit F12, we can see that save game only has an ID number. So it only has one property. It does not have a game property. So TypeScript is checking for us and making sure that I'm referencing the right properties. So now I can do save game. I can return my ID back. So that's pretty cool. I think this is like one of the most powerful features and one of the best things I like about using TypeScript with React. Doing this sort of discriminated union is really powerful because it makes sure that my actions are going to be consistent, and if I update my actions, my reducers are going to throw compiler errors, so I can make sure I fix them before I get too far. If you don't want to do a switch statement, you could do something called an action map. This is another way in Redux to do handling for reducers. Instead of defining a switch statement, what you can do is just define a dictionary. So what this dictionary looks like is something like this. I'm creating an actions constant, and it's a JavaScript JSON object. And the keys of that JSON object are my constants. So I'm just using the computed property syntax there. And then I'm referencing these individual smaller functions down below. So if you don't want to have a big switch statement full of stuff, you could do it this way. And the way that I'm typing this is very similar. I still have my type game option, or game action, and I still have my type of initial state details. But what I've done here is I'm just using a type alias just to shorten that up. So type aliases are super nice. You can just shorten long type names up. So now this is just state. So I can say I have my reducer actions that have my type state, game action, and what's cool about this is that I can change this to be, for example, save game action, and I still get the same type checking. So game does not exist on type action. So this is another way to do it. What do these helpers look like? Again, this is getting into more crazier TypeScript syntax, but the premise is still simple. So I'm creating an interface. This is my contract for my object. And I'm using this syntax right here. These square brackets mean this is an object that I can index into. And that property key is of type string. And the value of that key, the value of that property, is going to be a function that takes state in action and returns state. This definition right here is the Redux convention for reducers, right? So I take my state, I take my action, and I just return the new representation of state. Now what we can do is we can just create a helper function that just sort of takes care of that boilerplate of checking to make sure that my action is handled. I handle my action if it's available, otherwise I just return my regular state. And this is all type checked. If you don't like this larger syntax or this more verbose syntax, what you could do is you could do a more compact syntax right here. So this is the same exact thing, but now instead of breaking these out into separate functions where I have to create a separate actions map and all that, what I can just do is just do it all here inline. So that's even a shorter way to do it. And this is still all type checked. If I hover over state, you can see that state is what I expect it to be. It has my ID, my game, because that's my details state. And that's coming from right here, type of initial state.details. So that's an even shorter way to do that. Okay, so review. What did we just do? We created strongly typed actions. So if our actions change across our code base, then our reducers can update. They throw errors. And if our state changes, actions will also throw errors. So we're making sure that it's just consistent across the code base. Therefore, when other members of our team are working on actions or working on state, if they update it and I update it, then we make sure that we're all in sync. Reducer action handlers are typed, so they're statically typed and they're checked. So my reducers make sure that we're handling the right actions. I'm looking for the right properties on my actions. We also have reusable type utilities now that we can use. And if actions or state change, reducers break. Action creators. These are those little functions that return new actions. So let's take a look at what those look like. So what I've done here is I've created a function called loadGame, and it's using this helper that I've made called action creator. What is that buying us, and what does that look like? Well, this is our typical action creator. If you're learning Redux, you'll see this pattern a lot. You're just exporting a function. I just prefixed it with underscore to not conflict with this one. And I'm taking my payload. What is a payload? Actions have a type property, but then they can have any number of other properties. That represents what's on your action. And I'm just saying that that's what a payload is called. It's everything but the type property. And I've created another helper for that called action payload. But regardless, I'm just spreading those properties over in my action. So you pass me whatever you want, and I'm going to make sure that I pass the right type for my action. So how can we get that to play nice with TypeScript? So we have our action payload type here. This is a type alias, and we're saying taction extends action. Here's my action up here. I'm just saying that whatever you pass me as a generic argument has to be related to an action, has to be like extended from action, which means that it must have a type property. Well, if I would just want to take all the properties except type, how could I describe that in TypeScript? And I'm using a utility called omit. This is not built into TypeScript, but I got it from a really simple, nice little blog post that sort of had some other nice TypeScript type helpers. But what this does is that you give it your type that you want, and then you give it a list of properties you want to omit. So if I wanted to, I could say omit type, omit game, or omit ID. And so I'm going to get an object back in TypeScript. So the compiler understands that I'm returning an object without these properties on it. You could also do pick. Pick is the opposite of omit, and pick is built into TypeScript. But this is the opposite. This is just give me these properties. But I don't want to do that. I just want to take all the properties except type. That's what omit lets us do. What about this action creator function? This looks a little bit funky. We're doing the same thing. So we're saying create an action creator for this action, and I'm going to pass it the type, the constant, the type that I want to pass in. And all this is doing is it's just doing the same thing that I was doing before. It's taking this little boilerplate and genericizing it. So here's my function that takes my payload. I am casting it as object because if I didn't do that, TypeScript's going to complain because payload has that type property. So it's getting confused. I'm just going to tell TypeScript, no worries, bud. Treat it as just a regular plain object. Spread the properties. And then pass in the type that I'm giving it. Type, 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 type. And force it to be a T action. It's just telling TypeScript whatever gets returned from this function is a T action. So now I can do this. I can just use this little action creator utility, and I get all the strongly typed benefits of this. So now I don't have to have this code anymore. I can get rid of it. And now load game. Load game, the definition of load game is a function that takes payload. Guess what? It even tells me what properties are going to be there, ID and game, and it's going to return a load game action. Load game action is right there, has an ID and a game. It's all statically typed. Fantastic. Now we need to dispatch an action. Let me show what that looks like. So I've created a function down here. This is not like a Redux action. What this is doing, I'm using a library called Redux Thunk. It's like the simplest way to sort of take promises for actions. And I'm using async and await. What I'm doing is I'm just creating a function that returns another function, and that function has a dispatch. So dispatch is part of Redux. It's the way that you send actions out for people to know about. So I'm being passed a dispatch handler right here. I'm just going to xkcd, I'm grabbing some JSON, I'm awaiting for it, and then I call dispatch. And dispatch, you can see here that I'm not doing anything TypeScripty right here. There's no TypeScript really in any of this. I am typing it right here. This is a built-in type declaration that's part of Redux. But it's all still strongly typed. So I have my load game, I have my dispatch, and once the fetch result is done, I am dispatching my action so I can mutate my state. What does that look like in a component? Well, here I have an example of a game details component. I'm doing the same thing. Where is dispatch coming from? I'm just using connect. So connect should look familiar if you're using Redux and React. I'm just connecting it. By connecting it, I'm getting that dispatch function again. And I'm just doing the same thing. I'm calling dispatch with fetch game. So that's all I need to do. There's no extra stuff I have to do with TypeScript because I've already done the hard work of making sure that my action is strongly typed. And Redux Thunk comes with its own type definition that handles these promises. So let me hover over that again. You can see here that we have an async action. This is coming from Redux Thunk. This is my game state. And then it's returning a promise, which means what I can do is this is all just strongly typed. Because it's a promise, do then result, and then whatever I want to do, console log result. And this is all strongly typed. So that's pretty cool. So like I just showed, it's all type safe with IntelliSense. So again, what did that buy us? We have some utilities now that we can get rid of some of this boilerplate for creating actions. Dispatch is strongly typed. I don't have to do anything extra with TypeScript to just get it to work. Because I've done all the heavy lifting in my actions, dispatch is all just passing the types through. So it's all about trying to maximize or minimize the number of type annotations that I have to have around my code. And we also ensure that actions are invoked with the correct arguments. I sort of showed this, but if I try to pass in something else, TypeScript's going to throw an error, right? Because fetch game is a function that only has a single argument called ID, which is of type number. So now if someone goes ahead, if another team member goes ahead and changes this action, that's why we have an action creator, TypeScript's going to understand that any reference to this function needs to be updated. It's going to throw a compiler error. One thing that's not so great about this is that you have to expose dispatch on props. So you maybe sort of caught that I wasn't using something like bind action creators or map dispatch to props. That's because you've got to do more boilerplate TypeScript stuff, and it's a lot easier just to expose dispatch. So you could be evil, and you could just do a global dispatch, and I wouldn't fault you for it because it would be easier to mock. If you're using jest, then you just do jest.mock store, and you just pass in your dispatch mock. So that's another option. Finally, the last set of patterns. Props and state, just for regular components. This, if you have used TypeScript with React, this shouldn't be a surprise. This is just the most basic stuff that you could do with TypeScript and React. So remember that I mentioned before that we have these types from React, pure component. So when you do regular JavaScript without TypeScript, you're still going to do this. You're going to do class extends React.pure component. TypeScript adds these extra definitions, these generic arguments. So the first one, like I said before, is props. The second one is state. These are just two interfaces that make sure that our stuff is strongly typed. By doing this, we get the type checking for JSX. We get the type checking inside of our state. All's cool. Stateless is even simpler. You got your function. It takes props. Your props are these. That's it. There's nothing extra that you have to do for that. Where it gets interesting is in more complex patterns. This is the render props pattern. Let's go into this. The render props pattern, if you haven't used it before, what it does is we define a prop on our component, and the convention typically is to use children. Children is a built-in property that gets sent to all React components. That's what's inside the tags, the JSX tags. Whatever's inside there gets assigned to children. And what we're doing is we're just typing that explicitly as a function. So the render prop pattern, what you do here is you take your JSX tag, and then inside of it, you use the JavaScript escape syntax with the curly braces, and we say props.children. I'm going to call you, I'm going to invoke you because you're a function, and I'm going to just pass you some new props because presumably this component is a little bit more involved than just this. This is my game image component right there, game image component. It might take some, different URLs for box art for a game, and depending on screen resolution, might return, a different sized image. What I want to do is I want to encapsulate that, and anything inside of it just gets past what the raw name, the image URL is, so we can just do alt source title. So then we can just render our image. So that's an example of the render prop pattern. But what I don't want to do is I don't want to just do this all over the place. So it'd be kind of nice if I could clean that up a little. And we can. All we really have to do is just pull it into a type alias. So type aliases, like I said, are awesome for just shortening stuff that you're going to be typing all the time. So rather than having to put this function type definition all over the place, now I've just created a render prop generic type that just takes whatever props you want to pass down. So render props are what's going to be passed to the children. So that's a nice pattern to do for that. What about connecting your components to Redux? This is a little bit more involved. And this is an approach that I found works pretty well. And it tries to minimize the amount of boilerplate type annotations that you got to do. Remember that taking TypeScript into your application is not like a small chore, and it's also something that your whole team has to agree with. As you can probably see, it's not going to be the simplest thing in the world, but you get a lot of really great benefits, especially if your team's going to scale. So when I'm saying trying to minimize the amount of type annotations, I just want to take advantage of TypeScript's inference as much as possible so that my team doesn't have to spend time updating type annotations all over the place. So in this case, we still have our props. I've just renamed it to own props. Own props, if you haven't heard the term before, is really just the properties on my component that do not come from Redux. State props are what I'm calling props that I get from Redux. Where are those coming from? Those are coming from map state to props. This is something you've probably seen in just regular, normal, vanilla Redux. This is the first argument that you can pass to connect. Map state to props takes in your state. Optionally, it can take in some own props. And then it returns state props. So all I'm doing here, I'm just hard coding this. I'm returning my image, name, and selected. Image, name, and selected is part of my state props definition. But I'm also passing these own props that are coming. So this component specifically is the game list item. And this is something I actually do in my app. Because people can reorder games, that's not coming from Redux, because if you're in the middle of a drag operation, it's not updating state. We need to pass that in as an own prop. So how can we tell TypeScript that we expect all of this stuff? When we finally get down to game list item, how can we tell TypeScript that all these properties should be available to us? So again, I'm using a type alias, and you can maybe see where this is going. I'm creating a type alias of all these three things. I'm using something called a type intersection. So this is different than a type union. A union is or, so there can be this type or this type, and does what it says. It combines the definitions of multiple types together, and it does it from left to right. So I'm saying take own props, add stuff from state props, also add the dispatch prop, and dispatch prop is coming from the React Redux type definitions. But again, I don't want to type this all the time. So what I'm going to do is I'm just going to take this dispatch and separate Redux state props, and I'm going to pull it into a utility, and we're going to call it SRC. SRC stands for Stateless React Component. That's what we want to call it in regular React. You can do React.sfc. I don't know if you've used that before. Sorry. Let's actually get some type checking. React.sfc. React.sfc is just a type alias for React.stateless component. So you don't have to type in stateless component all the time. So in our case, we don't want to type in, stateless Redux component all the time, where you can just type in SRC. What SRC does is it encapsulates that little type alias that I had before. So we are taking our state props and our own props, and guess what? Because we can set defaults, we can also just make it optional. Maybe it doesn't take own props. Maybe there's just props from Redux. In this case, we do have some own props, so I'm going to add it back in. Okay, that's cool. What does that look like? Man, there's a lot of stuff on here. On the first one, we have something called Redux props. Redux props are just our regular type alias that you saw before. This guy. Own props, state props, required, blah, blah, blah. What we're doing here is we're just being able to set a default, and then we're just doing that same type intersection. So this T state props, generic parameters, you can just give them a name if you want to. This could just be tfoo, and then we have a type error. But again, with the power of TypeScript, I can just call this tfoo, renames it. So we have tfoo, which are our state props, own props, etc. So that's just a shorter way to do that. And then we encapsulate the React.stateless component. And you're going to make fun of me because what I should have done is I should have done SFC, right? So now we have stateless functional component. And the props that we're going to pass it are our Redux props. And the cool thing about that is that we can then reuse that also for ES6 classes. So this is extending React.component. That's just the default React component. And again, the first generic parameter is my props. So it's of type Redux props, and then tstate. And you can see that I'm just setting these all to default objects so that at the bare minimum, I can just say extends Redux component without passing in any extra generic parameters. Fantastic. So what did that buy us? We have a way now to model splitting that own props and state props. So now they can be separate interfaces. I've shown you how to substitute those inside of your own type utilities. We can reduce a lot of like excessive type intersections to get that dispatch onto our props. We've created some reusable type utilities now we can use throughout the code base, so other team members can take advantage of them. I also showed you how to do render prop pattern typing so that you have a consistent way to describe render props. And you can go down the rabbit hole for that one if you have different types of render props that you want to do. So all together now, if you have been following along, you may have seen that there is a GitHub repository with all these patterns. So all this code that I'm showing you right now is all available for you to play with, peruse, submit PRs, tell me I'm wrong, that kind of thing. Fantastic. I just want to say before I end that there's always room for improvement. I've given this presentation, this is the third time, and I totally revamped it for NDC because there were so many new patterns that I've been learning. And there's always room for improvement. And I'm sure some of you in this room who have used TypeScript and React might have your own patterns, and I want to know about them. So open up an issue on the repo, or send me an email, or tweet at me. Send me your patterns. I'm super interested. I'm still learning React. I'm fairly new myself, so I hope that if you have been using React or you're new to React and you want to try to use TypeScript, I've given you some patterns and practices to help you create a little bit more maintainable, reusable code. So with that, thanks for listening. We have some time for questions, if there are any, before I finally end. Yes, sir. Yes. There it is. Any other questions? Yeah.
The bottom-up state, how is it actually assembled, and when you kind of get it up and kind of maintain this one state?
Sure. So your question was about the bottom-up state and how is that maintained between, like if I'm using React Router or something like that. So if we go to the very root of my state, so all we're still doing all the normal stuff that you would do with Redux, where we're just creating our default state. So that's going to be our full object that describes our application. And this is just using imports to compose all of our subscreens together. So at the end of the day, you're still going to have a final state. In fact, we have a little bit of time. What I'm going to do, we have like a minute or two. I'm just going to start this application. There shouldn't be any errors. And we're going to have a little, that's fine. Let me just undo these. So I'm using Create React App for the sample. I don't have the dev tools on here. I don't have the dev tools open, but what you would see is you would just see the whole entire application state composed as one. So you could use this if you want to with like code splitting for Webpack. So maybe each of your screens are probably going to be routes, right? And so then when you could do dynamic imports to compose your state together. And so you could still do type checking and all that if you do dynamic imports. Does that help? Cool. Any other questions? Otherwise, let's get back to the final slide. Thanks for listening. You can follow me on Twitter or find me online at kamranicus.com. If all this TypeScript stuff kind of went over your head, I have an 8-hour course that is going to take you from 0 to hero. So in that course, we actually migrate 3 different JavaScript code bases to TypeScript, and I go through all the stuff that I just talked about in more detail. If you're interested, there is a Midwest.js version of this talk that goes into some more performance type stuff, but that was so much content that it just needs to be a whole separate talk. But with that, thank you all so much. Have a great rest of your conference.